Loading one of these massive, modern container ships, it's like trying to solve one of the most complex, high-stakes puzzles on the planet. You're dealing with thousands of tons of cargo, all these shifting variables, and, of course, the unforgiving laws of physics. If you get just one single piece wrong, well, the consequences can be absolutely disastrous. So how in the world do the masters of these modern leviathans solve this incredible puzzle, day in and day out?
I mean, how do you really do it? How do you make sure a floating city of steel and cargo stays perfectly balanced, perfectly stable, and ready to handle the immense forces of a storm out at sea?
Well, you don't do it alone. You rely on a powerful digital co-pilot. And for maritime professionals all over the world, that essential tool is the MACS3 loading computer. You can think of it as the digital brain behind the incredible brawn of global shipping, turning what could be a chaotic mess into a precise, calculated, and safe operation.
Okay, so what you're looking at here is basically our roadmap for this whole explainer. It's called the MACS3 port call workflow. This is going to be our guide as we see how this whole system works, from the moment a ship starts planning its arrival all the way to its final departure.
We're going to break this whole journey down into 4 key phases. First up, we'll look at the critical planning that has to happen before the ship even gets to the dock. Then, we'll dive into the real-time problem-solving that goes on right in the middle of the chaos of loading. Third, we'll cover the final checks that certify the vessel is actually seaworthy. And finally, we'll zoom out and look at the whole ecosystem that makes all of this possible. All right, let's dive right into Phase 1, pre-arrival. This is where the digital foundation for a safe and a successful port call is laid, long before a single container is ever moved. So the whole process kicks off by creating a perfect digital twin of the vessel, exactly as it is right now. That means inputting the precise levels of every single tank. We're talking everything from ballast water to fuel oil, and accounting for any other constant weights on board. Then, the officer imports the proposed stowage plan from the terminal. And this is where MACS3 really starts to shine. It immediately runs a whole battery of automated safety checks on that entire plan.
And believe me, this is way more than just a simple once-over. The software scrutinizes every single detail. Is the ship's stability within safe limits? Are the stresses on the hull, the shearing forces and bending moments, all acceptable? Are the lashing systems actually strong enough to hold down the stacks? Is the view from the bridge clear? Are the dangerous goods properly separated? It checks dozens of these parameters to catch potential problems long before they ever become real ones. Okay, so the plan is set. Now we move on to Phase 2, import. This is where that perfect digital plan meets the fast-paced, often unpredictable reality of the terminal. And this is where things get really interesting. So picture this. It's a super common scenario. The stowage plan calls for a really heavy container to be stacked right on top of a much lighter one. This is a classic heavy on light error. It might seem like a small mistake, but it can create a serious stability risk, especially if you hit rough seas.
MACS3 immediately flags this in the condition check window, but here's the really slick part. It doesn't just point out the problem. The fix is brilliantly simple. The officer just holds the shift key, clicks the 2 containers, and the software instantly swaps their positions in the plan. The warning disappears, problem solved. What could have been a serious risk is fixed in literally seconds. All right, here's another one of those real-world headaches that pops up all the time. A last-minute change comes in from the terminal, and suddenly you've got a high-cube container, one that's taller than standard, slotted to go into a hold where it just won't fit. The result? A stack height hold failure. And again, the solution is just as direct. The officer goes right into the system, edits that container's data, changes its ISO type to match the standard container that's actually being loaded, and boom, the software recalculates, the failure is cleared. It just shows you the kind of flexibility you need during these active operations.
So you might be wondering, how does all this information get from the terminal to the ship and back again? Well, they speak a special language. It's called BAPLI. It's the global standard, this electronic file that contains every single detail about every container and its exact stowage position. It's basically the digital handshake that keeps the ship and the shore perfectly in sync. And this diagram, it perfectly shows what happens when that final BAPLI file arrives from the terminal after all the loading is done. Now, MACS3 doesn't just overwrite the old data. It does something much smarter. It intelligently merges the new information with the ship's current condition, which preserves any of those manual adjustments the crew might have made. The result is a final loading condition that is a perfect mirror of what's actually on the ship.
This brings us to Phase 3, departure. The cranes have gone quiet. The last container is lashed down, and it's time for that final, absolutely critical sign-off. And this right here is the moment of truth. The officer runs the condition check one last time, and what they're looking for is this: a screen full of green lights. Each one of those green lights means a critical safety parameter, from stability to hull strength to dangerous goods, is within acceptable limits. All green is the ultimate confirmation. The vessel is safe, stable, and ready to sail.
And here's a really crucial point. Once the vessel is confirmed to be seaworthy, MACS3 kind of changes jobs. It goes from being a planning tool to a super powerful reporting engine. It automatically generates all the essential documentation for the voyage, creating that vital paper trail for port authorities, for customs, and for the company.
And getting to all these reports couldn't be easier. It's right there in the main menu. Officers can access this huge list of pre-configured reports. With just a few clicks, they can generate everything from a full departure report to a simple logbook entry.
And we're not talking about just some generic printouts here. The software can generate highly specialized documents, like the specific report that's required by the Suez Canal Authority, or a detailed cargo summary that's filtered to show only the containers that are destined for the very next port of call. It's all about providing the right information in the right format exactly when you need it.
All right, for our last section, let's zoom out a bit, because you have to understand MACS3 doesn't operate in a vacuum. It's actually the core of a complete ecosystem that's built around safety, security, and the competency of the crew.
You see, this whole ecosystem covers everything from the physical hardware to the professional skills of the crew. On one end of the spectrum, you've got this physical hard lock. It's a USB key that acts as a security device, making sure only authorized software is being run. And on the other end, you have the MACS3 Ready certificate, which validates that an officer is truly competent through rigorous training and evaluation. And of course, a whole support network is baked right into the software itself. Got a question? Just hit F1, and a context-sensitive manual pops up. Find a bug? You can generate a super detailed error report to send to the support team. Need to brush up on your skills? Full training courses are available. The whole system is designed to make sure users are supported every single step of the way. You know, there's this quote from the training materials that I think just nails it. MACS3 can assist greatly in ensuring the safety of a vessel. It is also a program that can save a lot of time and make the stressful life on board a seagoing vessel more efficient. It's really about those two things, right? Safety and efficiency working hand in hand. So, that kind of leaves us with one final thought. In an industry that is defined by immense complexity, where the margin for error is practically zero and the stakes are just incredibly high, the real question isn't just about how these systems work, but whether any modern vessel can truly afford to sail without its digital co-pilot.